So yes, that's the title of my presentation, but actually, well, I think I'm gonna do something very similar to that, which would be around some story that I have. And that story combines elements of data and AppSec and innovation, and it's all tied to some destiny, my destiny in that sense. So let's try to move forward, and well, doing a short introduction to myself. I'll do that really quickly. Former OWASP Israel chapter lead. I'm really proud to doing that role and contributing to the OWASP community. I'm data-driven security researcher, which means that I work a lot with data, and data drive a lot of my research. As was mentioned, when I try to define my role as a security researcher, and there is a lot of definition for that. My definition is that I'm trying to move security challenges into the science and solution space, hopefully doing that correctly. And last but not least, I have really boring social network persona, and therefore I don't encourage any of you to follow me on Twitter or _Katz. Really boring, don't do that. Let's continue. So where the story start? So the story has some background, and I will share with you some of my background. I used to work in one of the first web application firewall vendors many years back. The name of the vendor was Bridge Security, and my role in that company was to do all the security research and maintain a lot of the web application firewall rules that the product has. And that was the time that, like, you need to explain customers what the difference between web application firewall and IDS IPS, why they need web application firewall. That was the discussion. That was the narrative of the discussion. And part of that work of trying to create those signatures and those rules to protect against web application firewall attacks, web application attack, was the fact that you had to, in a sense, try to create signatures and rules that can enable protecting from a variety of attacks, but those attacks had a lot of permutation. For example, and we'll talk about SQL injection in this presentation. When you talk about SQL injection, it's based on SQL language, right? And there's a lot of permutation of that language and a lot of variant of different SQL server and some of their syntax. So you have to make sure that you have all the permutation, all the things that can be done, and that's a really challenging kind of work. Right? And that's a bit of background about me and my, where I started my InfoSec career. Now, the story actually started, I would say 5 years ago, I think. I was traveling to San Francisco, and I was supposed to stay in an hotel, and I was getting into the hotel lobby, and I met a colleague of mine, and my colleague was saying, hey, man, you need to go to the frequent user website of that hotel, because if you will do that and you will register, you will get a discount. So I was trying to do that. I was getting into that website. I wrote my first name, last name, and I got this answer, right? That's the shock part. And or are not allowed as first and last name fields, right? Whoa, so I'm not allowed to be registered to that hotel? And that really shocked me. And when I started thinking about it, I had a theory, right? And in my theory was the fact that I was saying, hey, maybe that's part of some protective detection kind of mechanism. They try to avoid web application attacks, right? For example, SQL injection. And the keyword or, which is my given name, by the way, might be used in the context of when someone tries to inject SQL injection, try to create a logical statement or inject logical statement into the SQL query. Now, that was my theory. And let me explain a bit about SQL injection. I assume most of you, if not all of you, are familiar with that, but let's do touch base and make sure that we are aligned. So what's SQL injection, right? You have a query, select from user where user ID equal to user ID, which is the actual value or payload being delivered from the user, right? Now, if you write really bad code, that given input will not be synthesized correctly, not be dealt with in a way that will avoid SQL injection. And how will injection will look like? This is an example of injection. Someone will add a value for the user ID, full or 1 equal 1. Once that gets into the query, then, again, assuming that there is a SQL injection vulnerability out there, then you will get a statement that regardless of the value that you will put, whether you put full or something else, the actual query will always be true. And that was, in my mind, the theory of someone trying to avoid those kind of attacks. But then comes the question, right, but OR by itself, is it enough to create SQL injection? The answer is no, right? It doesn't supposed to be like that. So I was saying to myself, okay, let's try to, well, prove that theory. Let's try to figure out if I'm correct or not. So I was trying to add a different payload as my username, and this time representing OR as double pipe. Now, why double pipe? Because in some SQL syntax, well, depends on the SQL server, double pipe represent also OR, right? A conditional statement meaning OR. And that was rejected as well, right? As you can see, the character pipe greater than, smaller are not allowed as fields. So that was the denial part for me, right? Assuming that someone wrote those kind of rules to that given web application trying to protect it, it's blocking a lot of things just because there is a portion or some part of payload that might be used as SQL injection, but it's not enough, right? You cannot execute SQL injection with just pipe or just the keyword OR, right? You need more than that. Now, moving forward, I was telling myself, okay, so that sounds interesting. Let's try something else. Let's try to put into my username value something that represents also a conditional logical keyword. And I was using the word XOR, right? Exclusive OR. And once doing that, I was accepted. So that was the anger part, right? This is when I started to be angry because someone is blocking OR, which is me, but XOR, my younger brother, is being accepted, right? That's not acceptable. I don't have a younger brother, but let's say that I have one and his name is XOR. So that got me mad. And I tried to funnel that kind of anger into creating something constructive. And I wrote a short blog about it, and I explained and tell that story, hopefully in a funny way. And that actually led me to a different kind of thing, right? Because a few years afterward, after that, registration incident and the blog that I wrote, I was, acquiring new skill set in the context of data science and data mining and stuff related to that. And suddenly I asked myself, maybe it's time for destiny to knock on my door. Maybe I should utilize two things. First of all, my new skill set and my ability to create, to work with data and create insight out of the data using machine learning and data science in that sense. And the second thing, I was working for Akamai, I'm still working for Akamai. And the one thing that we definitely have a lot of is data. And I was asking myself, maybe I can utilize the huge amount of data that we have in Akamai, that, portion of data of the internet, and a lot of that data represent attack vector. How can I utilize that in order to create a process that will enable me to create better rules, right? To create better signature that will serve or help with building web application firewall signature. That was my goal. And I call it rule them all. And as you can see, it's like there is a regular expression into that. And it's 5-step process, right? 5 steps for that. First step, collecting and cleaning the data. We will use a huge amount of data. We have to collect the data in a way that will be where we will be able to use the data, but we have to make sure that the data is clean. There's no punctuation, there's no garbage, let's call it like that, into the data. So we'll talk about that. That's the first step. Second step, choose the keywords. We will use a huge amount of data, and therefore we will have a huge amount of keywords that can be used. And we need to make sure that for two reasons. The first reason, from a computational point of view, we need to make sure that we have a limited amount of keywords that we can use. And the second item is that there's a lot of keywords that might not get in or shouldn't be getting into the data that I'm working on, and that was ability to take them out of the data. So that's step number 2. Step number 3, we will create a matrix, which will represent something for us to work with, because that matrix will enable us to move to step number 4. And in step number 4, we will create relationship between different keywords and how similar they are. What is the similarity between those keywords? That will be step number 4. And once we're done with step number 4, we will move to step number 5, which will be clustering those keywords, trying to create some insights out of those clustering, trying to make sure that those keywords that appear together has some meaning in that context, and we might have insight out of that. And we'll get to that phase later on. So let's get started. We'll do that really, really quickly, right? Step number 1, because we don't have a lot of time. Step number 1, collecting the data. So in order to present that, I use a case study with 7 payloads, 7 SQL injection payloads. But as we will move forward, we will see some example of things with much larger scale and much more payloads to be used. So in those seven payloads, what we can see, well, different payloads, some of them relevant to some SQL syntax, some relevant to other. Well, it's randomly was chosen, right? It's not the issue here. But what I want to show you here is that I will do some process of cleaning the data. And what does that mean? For example, we have payload number 3, which is wait for delay with 7 seconds, and minus at the end, which is a comment in the context of SQL syntax. And when we talk about cleaning that, that means that we will remove some of the punctuation. We will take, for example, the 7 seconds that are being used in that case for the wait for function. It's a Postgres function as far as I remember. And it's being used mainly for blind SQL injection when someone tries to penetrate into the SQL query and run some slipping to make sure that the code was actually executed, and the fact that you were able to penetrate into the SQL context and run that on the SQL server. And it could be 7 seconds, it could be 8 seconds, it could be also 20 seconds, right? It can change. That doesn't change the meaning of the payload. And therefore, we were doing some normalization of that and putting a placeholder called blind SQL time, right? That's the format for that. The minus at the end, that's another example of something that means commenting in the context of SQL. So therefore, we put some sort of a placeholder for that as well, representing n of is SQL. So that's an example of cleaning the data. And this is the same 7 payload that you see on the top of the screen now being cleaned and sanitized and ready to work with. Moving to the second step. The second step is, as I mentioned before, it's trying to choose the keyword based on their frequency. Now, why that's really important? In the context, 2 reasons for that. First of all, we have limitation on the amount of keyword that we can choose, but more to that, as we will move forward, we will talk about the fact that some keywords with higher frequency might lead us to do some changes in the way that we write our signature or reorder the signature that we are writing, because highly frequent keyword, assume relevant, means that we would like to match that keyword before other keywords that are not as frequent and is not as relevant, because that might improve some of our performance from a signature engine point of view. And we'll talk about that later on. So you can see I took all the keywords and created some sort of a frequency for those keywords. Moving to step number 3, what we were doing is the matrix, right? Keanu Reeves style, but without Keanu. So the matrix is the following. What you can see here, there are 7 lines representing 7 different payloads. And in the columns, you can see the different keywords that we chose. And on each line, you can actually see whether a given keyword appeared on a given payload. So before moving to the next one, so what we would do, the next step for that, we will do transport for the same matrix, right? The same thing, we will do some transport for that. Now the rows are the keywords and the columns are actually the payload. And why that's important? Because now we have the ability to look on, for example, a couple of keywords, select from, right? Both from SQL syntax keywords that obviously we are familiar with. And now we can start to see some relationship between them, because what we can see here is that selected from appears together on payload number 2, 3, 5, and 7, right? That's a good thing. That means that they come together. That creates some sort of a relationship between them. But we can also see that payload select, well, the keyword select appear on payload number 6, but didn't appear on that. Well, and form didn't appear on that same payload, right? Which means there is a similarity, but it's not perfect. Sometimes select appear without a from. It could happen. How can we use that? What is the purpose of that? The purpose of that is that the next step, which was to create a relationship between those keywords, we use a Jacquard index algorithm to represent a relationship, a numeric relationship between 2 vectors. What we saw before is vectors. The calculation of Jacquard index is the the intersection of 2 vectors divided by the union of those 2 vectors. And let me explain that briefly, right? Again, the select and from example, what you can see here, as we mentioned before, select and from appears together, that's the intersection on payload number 2, 3, 5, and 7. And therefore, therefore, there are 4 values of that, but we know that when we do union of them, we have 5 because we also saw payloads number 6 with only select. Now we take and abstract one of that value because we want to normalize that and create a value between 0 to 1, and we get the value 0.2. Now, what we can see here, now that we have a numeric value between 0 to 1 representing the similarity or the strengths between 2 keywords, as closer as that value is to 0, that means that the strength, they are much stronger. They are much more similar in that context, right? So that's what we see here. That's an example for that. Moving into the 5th step, where we're doing clustering. In our case, we were using hierarchical clustering. We start to see some of those clustering. Again, this is a case study. That's an example. And what we can see here, for example, that select from were clustered together according to the algorithm, and the score of the clustering was 0.2. Now, that's not all. We can also see that union joined that cluster later on, and that actually changed the score of that cluster to 0.4. The number represents the strength of those keywords appearing together, and that number might use later on for us to decide whether we want to use the relationship between these keywords or not. It might be that the value of that clustering is way too high, therefore the relationship is not that strong. But if the value is really, really low, it's close to 0, that means that they are really, really similar, appears together, and therefore we can use that for other purposes. Now we did that. Now moving to the next step, right? As I mentioned before, that was just an example. Now let's go to the real world example. And in order to do that, we were using clustering of over 500,000 unique SQL injection payload. I will say that again, 500,000 unique SQL injection payloads. It's a huge amount of data, right? And what we were able to see as part of that is that we start to see some things that were interesting for us. The first thing that we're able to see is that our intuition really works. And what does that mean? For example, we saw at the beginning of the presentation, the wait for delay. Wait for delay are 2 functions that works together. They cannot be separated. It's a joint functionality in that sense. And therefore, we were able to see as part of the data that we were analyzing that the wait for delay are actually always or almost always appear together. If they are not appearing together, that's it's a mistake. And that gave us an indication that our intuition works as expected. We saw other examples, for example, then, else, and, which are conditional statements being used in SQL. And that gave us the good indication that we are on the right track, we're doing the right thing. The second interesting thing that comes to mind when we look into the first and initial graph that you see here on screen was the fact that we started to see some keywords that were not associated with SQL syntax being coupled together. And those keywords were, for example, name of columns and name of tables. So what is the meaning of that and how that's usable? So try to imagine that someone is executing some widespread SQL injection attack on some vulnerability on WordPress, right? And that given WordPress plugin that is being vulnerable has in the background some database, and that database has tables and has some columns. And when someone tried to exploit that, he was using those values, and those values are unique to that given database. But once they appear a lot, as part of the process that we were running, as part of the analysis that we were doing, we started to see those coupling comes together. And that gave us the ability to put some spotlight on things that we were never being aware of that being executed out there. So it's in a way, it gave us the ability to start to see some campaigns, some SQL injection campaign, abusing some vulnerabilities. And it led us to do some priorities of dealing with those kind of attacks and trying to figure out if we have the better, if those applications are really protected, or if those applications are actually vulnerable. Is it a known vulnerability? Is it a new vulnerability, a zero-day vulnerability? That was part of some things that we were able to see out there. Now, here comes the part that I was speaking very quickly, and I will start to speak a bit slower, which you might ask yourself, okay, so it's a nice project. It might be a nice project. You might think it's not. Full disclaimer: I'm not considering myself a data scientist or machine learning expert. It's not what I acknowledge myself as being one. And therefore, if you think, and if you are a data scientist and you think that there are better ways to do what I was doing, you're probably right, there are. So that's important to put that into mind. But you might ask yourself, okay, so it's a nice project, what can we do with that? What's the implication of that? So a few of those. Again, and bear in mind that my objective was to try to create some research project that might help those that write signature, because it's really, really manually processed, really challenging, really complex in that sense. And if I will get some insight that will help write those signature rules, that might help in the context of making those rules better and making the effort of creating them much easier. So few of those things that can be used. First of all, improve signature detection, right? So once we are doing that and collecting those keywords, and again, we don't know the payload. We just saw a bunch of payload and we just processed them. And once we did that, we were able to see some keywords that were chosen. And we looked into those keywords and tried to figure out if we have those keywords as part of our signature files, right? If we have those as part of the signature that we created for our web application firewall. And if, for example, there is a keyword that was not used as part of the signature file, we might want to add them. So that was the first part. The second part here is that, and it's the most important one to the best of my knowledge, which is concerning improving performance and efficiency of signatures. So two use cases here. First of all, frequency of matching payload, right? So we saw the fact that we saw some frequency of the keywords that were used as part of the 500,000, for example, payload that we're able to see out there. Now, if a given keyword appears a lot in high frequency, as I mentioned before, maybe that should be matched before others, right? And maybe that will affect, depends on the implementation of our signature engine, that might affect the way we perform once we are doing matching for those signatures. So that's the first case. The second one, which is more interesting, is the fact that we start to see coupling of keyword, and as strong as that coupling and as strong as that clustering between those keywords, that can lead us to say, hey, maybe we have the ability to take those different keywords that comes together and create signature out of that. A simple signature that does not use regular expression, because they appears to get together, they have some order, and they are really distinct. And in that sense, if I create a signature that is not as complex and it's not highly efficient as regular expression, I might take some of my regular expression and retire them and replace them with simple patterns. So that was the second item. And the third one is find new exploit and explain about it on a previous slide, which is the name of the columns and the name of the tables and the coupling and our ability to put some spotlight into that. So those are the implications that I was using and I was presenting as part of my research. Now, we are at the end of the presentation, right? We have 5 more minutes and we'll give some minutes for questioning if we have some. So what is the purpose of this research, right? So obviously, as I mentioned, I'm not a data science or machine learning expert. It's not the issue here. The issue for me was the fact that our ability to take some problem that we had in the past that created a lot of challenges for us, that we used to solve in a manual way. As we move forward in the technology stack, we have new capabilities, we have new ways, and we can use new innovation to create some solutions to try to solve those old things. That's from a research point of view, and that's my state of mind and how I do some of my research. More to that. The joke is on me, right? My first name is that's my given name. That's not a nickname. That's not something else. So it's okay to sometimes tell jokes and stories about yourself. We should do our job really seriously, but we can take the time and joke a bit and laugh about ourselves. That's okay. And if you wonder or you ask yourself, what's the meaning of Or, right? It's a really short name. Why my parents gave me that name. So Or in Hebrew means light. That's the meaning of that. So I hope I was able to enlighten you today. I hope that I was able to share something that you might use and will help you do other things as well. There is a blog that I wrote about all this process and some of the things that I presented here today. You can definitely go and look into that if you want to. Thank you very much.